Hi, welcome to lesson 9.2, special right triangles. All right, for today's lesson, you are going to need 2 half sheets of paper that you are going to glue, one on page 247 and the other one on page 248. So pause the video, make sure you get those glued in, and then start the video whenever you are ready. Once you're ready, turn to the next page, and I'm going to show you guys where the problems are going to go. So please make sure you write down where exactly they're going to go. So number one is going to be a really small problem. It's going to go right up here for problem number 1, problem number 2, problem number 3, and problem number 4 down here on page 249. So let's go back to the beginning of the lesson here. Now, today we are going to focus on 2 types of right triangles, you would say. Okay, so this whole chapter mainly deals with solving for parts of right triangles. In lesson 9.1, we learned of the Pythagorean theorem. Now, in the Pythagorean theorem, you only needed 2 of the sides in order to solve for the next side. However, that did not help us when it came in terms of solving for the angles. So today in this lesson, we're going to look at 2 special types of right triangles. Now, all these are going to be right triangles. Pythagorean theorem can be applied, but sometimes they're only going to give you one piece of information, so we need additional tools for that. So let's first start off with what we call the 45, 90-degree triangle. So how do we develop something like this, or the skill set for something like that? Well, it's very simple. Let's first start off with a square. Okay, and we know a couple of things about squares. We know that they all have right angles. And we know also that all the sides are congruent. So if the value of x is this side, then so is this. Now, because this is a square, we do know that the diagonals bisect the pair of opposite angles. We already knew that back from chapter 7. So if I were to draw one diagonal, that's going to give me this angle right here to be exactly 45 degrees, and this one also 45 degrees. So let me redraw this without the rest of the triangle. So if I got something like this, if I have a right triangle and both of the legs happen to be the same, 45, then this is going to be a 45, 90 degree triangle. And it works both ways. Okay? If you have a 45, 90 degree triangle, then the legs are going to be congruent. And if you have a triangle whose legs are congruent, then this is going to give you a 45 degree triangle. Why? Because this is going to be isosceles, and we also know that the opposite sides of the 2 congruent pieces are going to give you, the same degree. And since this one's 90, we can easily figure out that the sum of these 2 is 90, cut that by 2, and you get 45. So now the question is, what is the hypotenuse going to be? Now, what we want to do is we want to write down the length of the hypotenuse in terms of the legs. So using Pythagorean theorem, we know that my c square is going to be equal to my a square and my b square, but my a and b are exactly the same thing. So here, this represents a, this represents b, or vice versa. That's going to give me x squared plus x squared. So when I solve for this, I'm going to get c squared equal to, now here comes the tricky part. You don't see these, but there's actually coefficients right there. 1 plus 1, that is going to give me 2x squared. Now what I want to do is I want to solve it for c. So I'm going to take the square root of both sides. So the square root of 2 and the square root of x squared. Now here's the cool thing. I can actually split this into the square root of 2 and the square root of x squared. But what I'm going to do for the sake of organization, I'm going to switch the order of these two. I'm going to rewrite this as the square root of x squared times radical 2. Now, this right here, the square root of x squared, they're opposite operations, and they undo each other. So c is going to equal x radical 2. So in terms of what we see here, we have here that the value of x is considered to be the legs. Okay, and c represents the hypotenuse. I'm just going to write HIP for hypotenuse. So what we have here in terms of the relationship is that the hypotenuse is equal, hypotenuse c is equal to the length of the leg multiplied by the square root of 2. So that's the relationship that we have with a 45, 45, 90 degree triangle. Okay? Now, there's only one relationship that we have in a 45, 45, 90 degree triangle. All right. Let's look at the next relationship. The next relationship is going to be for a 30, 60, 90. Okay, so turn the page. And this is going to be for a 30, 60, 90 degree triangle. So how do we get to a 30, 60, 90? Well, it's very simple actually. What you need to do is you need to first draw an equilateral triangle. Remember, equilateral triangle and equiangular triangles are the same. When you do that, all the lengths are going to be the same. And every degree that you have here is going to be 60 degrees. So when you drop, including this one too, when you drop a perpendicular from the top vertex down to here, you're going to get a right angle. Okay, in order to figure out this angle, you have to do 90 minus 60, which is going to give you 30. Now, remember that this whole side right here and this whole side right there and this one is the same. Okay, so because this is a perpendicular bisector, this length right here is going to be half of the hypotenuse. So if I say that this leg right there is x, the hypotenuse is going to be twice as that. Why? Because this value right there is also x. So altogether, this is going to be 2x. Now, that brings us to our first relationship. You notice that this triangle has two different legs. Okay, so I'm just going to redraw this without all the other information. Okay, so this is going to be 2x, x. Now, you notice that this happens to be the shorter leg. Okay, and this happens to be the hypotenuse. So the first relationship that we have here is that the long leg, oh, actually not the long leg, sorry. The hypotenuse is going to be the product of the short leg multiplied, oh, I shouldn't use x because that x right there, okay, multiplied by 2. Okay, so if you know the hypotenuse, cut it in half to get the short leg, and then let's see what's going to happen with the long leg. Now, we do know that this is 30 degrees. My goal is to figure out what the heck is my long leg going to be, okay, because this right here, the one that is right across the 30 degrees, this one here represents the short leg. Therefore, the other one is going to be the long leg. So say that one is going to be B. We're going to call it B for now. Let's use Pythagorean theorem. So if I use Pythagorean theorem, I'm going to have 2x quantity squared, because remember, that's my C. And then I'm going to have x squared plus b squared. And what I need to do is I need to solve it for b. 2x quantity squared, back from algebra, that's going to give me 4x squared equal to x squared plus b squared. Now, I'm going to solve for b by subtracting x squared. No, that's not going to cancel these out. Plus, I don't like the word cancel. 3x squared equal to b squared. Take the square root of both sides, and you're going to get b equal to the square root of 3 times the square root of x squared. Now, this right here is just going to be x, so I'm going to go ahead and put that right at the front. So x times radical 3 equals b. So that brings me to my second relationship. My second relationship is the following. Okay? The long leg is going to be equal to the short leg multiplied by radical 3. So those are the two relationships that we have for a 30, 60, 90. Okay? And we're going to use these. And we're going to do something on a few called rationalizing the denominator. So watch out for that. Okay? So let's go ahead and look at the actual theorems now. So the 45, 45, 90 triangle theorem states that the length of the hypotenuse is equal to the length of the leg times radical 2. That one's easy. The next one, the 30, 60, 90, is telling you two properties. The first one is that the hypotenuse is equal to the length of the shorter leg times 2. How do you know which one's the shorter leg? It's the one that is across the 30-degree angle. The longer leg is equal to the length of the shorter leg times radical 3. So depending on the information that you have will depend on which one of the two you're going to use. If they give you the hypotenuse, all you have to do, cut it in half to get the short leg. If you have the short leg, all you have to do is double it to get the hypotenuse and multiply by radical 3 to get the length of the long leg. It's when they give you the length of the longer leg and they ask you for the short leg and the hypotenuse, that's when things get a little bit tricky. Okay, so we're going to look at a few examples of those in just a second. So let's go ahead and begin with our first examples. All right, so let's take a look at example number 1. It says, find the value of x and write your answer in simplest form. So looking at the first example, you can see here that you have a 45, 45, 90-degree triangle. How do you know? Because it's a right triangle, this one's 45, and if you do the angle sum and subtract from 180, you're still going to figure out that this one here is 45. So here's the thing. They're not asking you for this length, but it's always good to just simply write it. That one is exactly the same. Now, to find the value of x, we need to go back and remember the actual relationship for a 45, 45, 90. So for a 45, 45, 90, we have the hypotenuse equal to the length of the leg times radical 2. So the hypotenuse in this case is x. The length of the leg is 8. And because they want it in simplest form, this is our answer. If they wanted the exact answer, then we probably have to plug that into the calculator and then get some type of decimal. So for this one right here, you notice that these two values are the same. That means that the legs are the same length, which makes this an isosceles right triangle, which makes it a 45, 45, 90. So we're going to use the exact same relationship. Okay, so in this case, we do have the hypotenuse to be 5 radical 2. How do I know that? Right across from the 90-degree angle. That's the hypotenuse always. The length of the leg, I don't know what that is. And then radical 2. So we want to solve for x, which means that we need to get rid of this radical 2. So we are going to divide both sides by radical 2. Those divide out, and interestingly, these divide out too. It won't always happen, but in this case, it will. So x is going to be simply 5. Okay, so x is going to be simply 5. So that's example number 1. Let's look at example number 2. So for example number 2, it says find the value of x and y. Now, we have two relationships here, okay, that we have to pay attention to. Okay, the first relationship is the following. Okay, we have the hypotenuse equal to the length of the short leg times 2, and we have the long leg equal to the length of the short leg times radical 3. So now the question is, which one of the two am I going to use first? Well, it depends on what you have. Okay, x here represents the short leg. We don't know the hypotenuse. So I cannot use this one right here because I don't know either one of these. So I'm going to use this one right here. So what am I given? I'm given the one that's right across the 60-degree angle, and that's the long leg. Okay, so the long leg here happens to be 6. The short leg, we don't know what that is. It's represented by x, and it's also the one across the 30-degree angle. So that's going to be x times radical 3. Now this is where it's going to start getting a little interesting, because my goal is to solve for x. And you're probably thinking, well, can't I just divide it by radical 3 and then just say that x is equal to 6 over radical 3? Well, in a perfect world, yes, but we can't do that. The reason why is because we are not allowed to have a square root at the bottom in the denominator. So we're going to do something called rationalizing the denominator, okay, in order to get our final answer. So how do we do that? Okay, you're going to look at the denominator, and you're going to multiply this literally by 1. Huh? Multiply it by 1. Yeah, look. Radical 3 over radical 3, that's 1. But what that's going to do is going to allow me to simplify this. Okay, so radical 3 over radical 3 is technically 1. So you're not making the fraction any bigger or smaller. And this is the part that gets a little confusing. So that's going to be 6 radical 3 over radical 3 times radical 3. That is radical 9, which happens to be 3. So then I can simplify this number with this number. I cannot divide these two, by the way. A lot of people will try to divide them. You can't do that. Why? Because you got the radical coming in first, order of operations. But I can divide the 6 into 3 to get 2. So here my x is going to be 2 radical 3. And that, ladies and gentlemen, represents the length of the short leg. Okay, so this is going to equal 2 radical 3. So now the only thing that's left is to find the hypotenuse. So remember, the relationship for the hypotenuse is the hypotenuse equals the short leg times 2. So we know the hypotenuse is y. The short leg, we just figured out it is 2 radical 3 and then times 2. When you multiply this, do not multiply the number into the radical. You can multiply the 2 times the 2, and then that's going to give you 4 radical 3. And this process that we just did right there, that is called rationalizing the denominator, aka don't get a radical in the denominator. All right, so that is example number 2. Let's look at the next one. Okay, for the next one, we have the following. It says the road sign is shaped like an equilateral triangle. Estimate the area of the sign by finding the area of the equilateral triangle. So one of the things that we need to remember about triangles, guys, is that the area of a triangle is 1/2 the base times the height. In this problem, we already have the base. The base is 36. Okay, the base is 36. But we don't have the height. So we need to figure out what the height is. So what we're going to do is the following. I'm going to redraw the triangle. I'm going to draw an equilateral triangle as best I can. Okay, where this is 36, the top distance is 36, and then keep in mind also, it's equilateral. That means that all sides are 36, okay, all of them, including this one right here. But when you drop a perpendicular bisector there, that's going to turn this one into 18 and this one into 18. Now this angle right here, we already know it's 60, and this one we know it's 30. So H right here is going to represent the height, which is the one we need. To find the area, I need the base and the height. I already have the base. Base is 36. I don't have the height. So looking at this triangle right here, H represents the long leg. So the relationship that we have is that the long leg, okay, is equal to the short leg times the square root of 3. Now, I already have the short leg. The short leg happens to be 18. So the long leg, H, is going to equal short leg 18 times radical 3. So look, I already have the height. I already have the base. All I need to do is find my area. So my area, call it A, is going to be 1/2 the base, which is 36, times the height, which is 18 radical 3. And we're going to leave this in simplest radical form. Actually, no, it says estimate. So that means that we're going to get a decimal. So how do we fix all this? Okay, very simple. 36 and 2, those divide out to give you 18. So the area is going to be whatever 18 times 18 is, 324 radical 3. Now, if I want the exact answer, that's what we have. If I wanted the approximate area, let me show you how to do this. Type in 3 to the calculator. You can see it. Okay. Square root, boom, you get 1.732 something. Times it by 324, and to the nearest tenth, we're going to get 561.2 inches square. And that is how we find the area of this. Okay, so that one was example number 3. Let's look at the last example. Now, the last example has 2 different parts to it. Okay, so what you have here is a tipping platform, zoom in a little bit, is used to unload trucks. You know, like if they have some cargo that they can just, let gravity do its job. How high is the end of the 80-foot ramp when the tipping angle is 30 degrees and then when it's 45 degrees? So we're going to look at this in 2 different scenarios. The first one and the second one. Okay, the first one where this one here is 30 and where this one here is 45 degrees. Now, my triangles don't even look like they're the same size, but it's okay. Let's fix them. There you go. Much better. I didn't go to college and take a class in drawing, guys. All right, now here's the thing. The platform itself is 80 feet long. So 80 feet long, 80 feet long. So what they want to know is the height. Okay, call that H, call that H. Now this one here is 45, this one here is 60. So I technically have 2 problems to do. Which one to do first? Doesn't really matter. I think this is probably the best one. Now, because this one here is the hypotenuse, remember the relationship that the hypotenuse is equal to the short leg multiplied by 2. Okay, so the hypotenuse is 80. The short leg, well, the short leg is going to be the actual height, H, times 2. Divided by 2 on both sides, and you get the height to be 40. So it's going to be 40 feet tall. Now, over on this side, we know we only have one relationship, okay? That the length of the leg times the square root of 2 is equal to the hypotenuse. So hypotenuse happens to be 80. The length of the leg is going to be h times the square root of 2. So once again, we need to solve for h by dividing by the square root of 2. And ladies and gentlemen, we are going to rationalize the denominator like we did before. So by what number do you need to multiply by? By the denominator. Square root of 2, square root of 2. That's going to give me 80 square root of 2 over 2 times 2. That's 4. Square root of 4. That would be 2. And then that reduces to give me 40 radical 2. So then that's going to be the distance. Now, if they wanted me to give the exact answer, I just plug this into the calculator. Okay? So those are my two solutions. Which one's taller? Well, definitely this one, because the square root of 2 is bigger than 1. So whatever this number is, it's going to be a lot taller than this one. And it makes sense because it's a bigger degree than the other one. All right. So this concludes lesson 9.2. Thank you for joining.